Good afternoon to all participants. I welcome everyone for the third session of third day of program. I once again welcome our chief guest, our resource person, Mr. S. Kavin sir, Managing Director, AB Technologies,
Thank you.
Chennai. He's in second time he's giving his valuable lecture in our FDP program. I welcome you, sir.
Thank you.
I hand out the session to Kavin sir.
Okay. So, good afternoon to all. Today, I will explain about solar-powered electric vehicle charging station. First, we want to know why we have to go energy storage system. If we get the energy directly, we can get energy directly from sunlight as well as wind energy conversion system or from any one of the fuel cell system. But here the drawback from PV system we get energy during daytime only. From wind energy conversion system we can get the energy from 6 meter per second to 4 meter per second to 16 meter per second. That means in between the cut in and cut out speed. If the wind speed is less than that 4 meter per second and more than that 16 meter per second, we can't get energy from the wind energy conversion system. Similarly, fuel cell also. So during the daytime as well as during the energy from wind energy conversion system, definitely we have to store the energy. So the energy storage, the main elements are battery, then supercapacitor. So these batteries and the supercapacitor we can use it for electric vehicle charging station as well as common storage energy storage system. This can be applicable for both grid connected system and vehicle. That means electric vehicle. So the battery is a very important one, but compared to battery, supercapacitor is cost effective. So in the energy storage system, one of the main drawback it will emit some carbon dioxide also. But these are the different types of energy storage system. First one is fossil fuel, then mechanical spring that means inductor, then electrical capacitor, then glycogen, electrochemical battery system, then thermal brick storage heater. After that, chemical biofuels. These are the different energy storage system. Among these, two best things are battery storage and supercapacitor. So in the battery storage system, we can store the energy with the help of batteries, and from the batteries we can give the energy to the load as well as our applications. And these are the main types of batteries. First one is nickel cadmium batteries, nickel metal hydride batteries, lithium ion batteries, then small seed lead acid batteries. So the main battery is lithium ion battery only. After that lead acid battery also we can use it. Then working of the battery, actually battery is a electrochemical device. That means it will store the energy in the form of chemical and then later it will convert into electrical energy. So simply battery is a device. It stores the chemical energy and after that it can convert into electrical energy. Actually, this battery having two electrodes. First one is positive electrode and the negative electrode. Depends on the current direction or the electrons flow direction. We can tell it as charging mode as well as discharging mode. Charging mode as well as discharging mode. Anyhow, battery is the electrochemical device. It can store the energy in the form of chemical. After that, it will convert the chemical energy into electrical energy. So this is the working for battery system. It's having already I have told the two electrodes. First one is positive electrode and another one is negative electrode. In between the positive and the negative electrode, we can store the energy in the form of chemical. Later we will get the energy, electrical energy across the positive electrode and negative electrode. Then during charging, the electrons will flow through positive to negative. During discharging, the electrons will flow through negative to positive. So this is the direction under positive mode as well as negative mode. That means charging as well as discharging mode. So this is the electrochemical reaction. Here you can see this is the reduction. Then during oxidation purpose, yesterday I have explained the same block diagram. So today I will continue with this block diagram, because with this block diagram only we can explain the electrical energy storage system as well as PV based converters. Then this kind of solar based charging station as well as grid tied electric vehicle. So this system mainly consists of, first one is PV panel. From the PV panel, we will get variable DC output voltage with different DC to DC converters and MPPT algorithm. We can track maximum power from the PV system, and this voltage actually, as I told, for single phase we have maintained 300 volt DC, and for three phase we have to maintain 600 volt DC. So the DC charger or bidirectional converter will convert the high voltage DC into storage voltage. That means the capacity of the battery. Later, this inverter will convert the DC voltage into AC. Then, with the grid synchronization, we can give this voltage to the grid. Then, through the bidirectional converter, we can form either buck mode as well as boost mode for charging the vehicle batteries as well as the battery management system. So, without any battery management system, we can't do energy storage. Actually, compulsorily we have to use battery as well as supercapacitor for storing the energy. So this is hybrid energy storage system. In the hybrid energy storage system, we can use more number of input DC sources. First one is battery, supercapacitor, or fuel cell. But these all are required. Definitely, it needs DC to DC converters to work under buck mode as well as boost mode. That means under charging, it will work it in buck mode, but in discharging, it will work it in boost mode. So we expect a constant DC link voltage, and through the DC to AC single phase inverter or three phase inverter, we can convert the stored voltage into AC. Then later we can give this voltage to the motor as well as inverter, motor. So this is the PV equivalent circuit. We can give the actually the solar panel consists of silicon dioxide plus aluminium. So silicon dioxide is the sand and aluminium is the insulator, that means conductor. So insulator plus conductor, we can tell it as semiconductor. So semiconductor means partially conducting device. So while temperature falls in the solar panel, electrons will flow. So flow of electrons, we can tell it as current. So I into internal resistance, series resistance and parallel resistance, it will fix the output voltage. So depends on the temperature and the resistance, we will get, that means aluminum material, we will get the variable output voltage. So this is the IV curve of the solar panel, and this is the PV curve of the solar panel. Then for battery, already I told we have to use battery converters. Under the battery converters, there are two types. First one is non-isolated converter, and the second one is isolated converter. So non-isolated converter means input is DC and output also DC. In between, there is no DC to high frequency AC conversion. Under this non-isolated converter, so many types of DC to DC converters are there. Boost converter, buck converter, buck boost cuck converter, buck boost cuck converter, SEBI converter, loop converter, Landsman converter. Like there are so many converters are there, but these all are non-isolated converters. Actually, in secondary side, if any fault current is there, means in non-isolated converter, we have to compulsorily enable dV by dt or di by dt protections. Otherwise, our input source will get failure. But in isolated converter, some another one stage is there. but this kind of problem will not come in the isolated converters. So there are two types of DC to DC converters. First one is non-isolated converters and another one is the isolated converters. So this is the bidirectional non-isolated converter. Here you can see there are two switches are there, one inductor and one capacitor is there. So from the PV, we are giving this voltage to which system? Our bidirectional converter. So bidirectional converter means if the switch works, battery, inductor, we can tell it as boost mode. If switch S1 has work means we can tell it as buck mode. While we receive voltage from the PV panel, our switch will work under buck mode. So how it's possible means it depends on the duty cycle only. If our duty cycle is more than 0.5, it will work in boost mode. If our duty cycle is less than 0.5, we can expect buck mode only. So this is the way our bidirectional converter is working. It's having two switches S1, S2, LC2. How the boost and buck modes are possible means we know the circuit of the boost converter. In the boost converter, next to the DC source, one inductor will be there in series. So similarly, you can see this is the battery. This is the DC source for boost mode. So next to the DC source, one inductor is there. After the inductor, one switch is there. Then filter capacitor. So this one is, we can tell it as boost converter. Similarly for buck converter, here you can see from the PV panel we will give this variable voltage to the switch D1 switch S1. So if you apply duty cycle less than 0.5, it will work with buck mode. Finally we can give this voltage to the battery. So during charging or during storage time, switch S1 will work. During the discharging time, switch S2 will work. So this is the main circuit of bidirectional DC to DC converter, simply modified version of the previous circuit only. So it's having two inductors and two capacitors, L1, C2. Actually this switch, here you can see this is the battery, then inductor, switch and capacitor. It's like a boost converter, but from this side you can see next to the DC source, positive, negative, one switch is there, inductor and capacitor. So we can tell it as buck mode. Next one is isolated DC to DC converters. Isolated DC to DC converters. In the isolated DC to DC converters, in between one isolation transformer will come. That means high frequency transformer will come. So if we give this DC supply to the high frequency MOSFET, why we are doing this means, actually if you transmit AC with 50 Hz, the time is 0.02 seconds will come. That means 20 milliseconds. So our body will feel that 20 milliseconds. If we go with microseconds, our body will not feel the voltage. That's why through this switch S1, we are making the DC voltage into high frequency voltage, high frequency AC voltage. Means more than 1 kilohertz, 10 kilohertz or 20 kilohertz or 100 megahertz, you can keep it. But if we increase the frequency, too much of the mean switching losses will come. So we have to keep almost 100 kilohertz or 200 kilohertz only. Also in the isolated DC to DC converters, we cannot use IGBT. MOSFET is the best one because switching frequency of the IGBT is maximum 20 kilohertz only. But for MOSFET, we can apply up to 150 megahertz. So compared to IGBT, MOSFET is best one in the isolated DC to DC converters. Then now we are giving the DC voltage to the high frequency switch. This high frequency switch will make the low voltage isolation transformer. Now the isolation transformer will carry forward the voltage primary side into secondary side. So I will tell the transformer definition also. Transformer is a static device It is used to transfer the power from one circuit to another circuit without changing any frequency. So from input side, we will give the voltage with 100 hertz or 1 megahertz, any of the frequency. In secondary side, we will get the same frequency because it's a transformer. So already I told the transformer is a static device. It is used to transfer the power from one circuit to another circuit. Then output of the transformer is AC only. So once again we have to make the AC voltage into DC. For that we have used the diode D2 and the switch S2 will do this work. Then we can give this voltage to the battery as well as load. Now here we have to control the bidirectional converter. For controlling the bidirectional converter, so many methods are there. First one is PI controller, fuzzy logic controller, artificial neural network controller, and a neuro fuzzy logic controller. So many controllers are there. Actually, already I have told less than 50% duty cycle it will work in buck mode, and more than 50% it will work in the boost mode. So we are comparing the. We will take the VPV and IPV. VPV means solar panel voltage, IPV means solar panel current. With this solar panel voltage and the solar panel current, we can apply any type of the optimization technique or intelligent control techniques. This control technique will give the reference signal. According to the reference signal, we can compare the reference and the carrier. Finally, we will get PWM pulse. So we can give these PWM pulses to the boost mode switch. Then for buck mode, we have to assign the reference voltage. So battery voltage. So nearly 12 to 14 volt we can set. So the reference voltage minus actual voltage, and the error is given to we can use PI controller, PID controller, then intelligent techniques fuzzy, ANN and neuro fuzzy. After that we can use soft computing techniques also. Then we have to compare the reference and the carrier. Here we will get the PWM pulse, but it depends on the reference voltage. According to the reference voltage, it will give the voltage. Next, controlling technique used for PI controller. Controlling technique is used to control the bidirectional converters. First one is the PI controller, second one is the PID controller, third one is the fuzzy logic controller, ANN and ANFIS controller. The PI controller, proportional plus integral controller. In control system, we have studied about the PI controller, proportional plus integral controller. In PI controller, the problem will come, it's like a maximum peak overshoot problem. That means it will take more settling time, rise time, fall time problem. So many problems are there. To reduce the PI controller, we are going with the PID controller. In the PID controller, it will reduce the maximum peak overshoot problem, but settling time is too high compared to the PI controller. That's why we are going to fuzzy logic controller. So fuzzy logic is the intelligent control technique. It's having external memory. It's having external memory. Artificial neural network, it's like our hidden layer. It's like a hidden layer. So the ANN controller is having internal memory. So if we combine these two, artificial neural network plus fuzzy logic algorithm, we will get ANFIS, neuro fuzzy logic controller. So compared to all the intelligent techniques, neuro fuzzy logic is the best one. After that, optimization techniques will come. So this is the structure of the artificial neural network controller. It's having three layers: input layer, hidden layer, and output layer. First one is input layer, second one is hidden layer, and third one is the output layer. In input layer, we can compare the reference voltage and the actual voltage, and this error is stored in the capacitor bank. Then after that, we will give this error to one PI controller, proportional plus integral controller. But that PI controller does not having, already I have told, any memory block. So in between that, we are using artificial neural network controller. In the ANN controller, there are three layers are there: input layer, hidden layer, and output layer. In input layer, we can store the difference between the reference voltage and the actual voltage, or reference SOC and actual SOC or current. This error is given to hidden layer, and the hidden layer will keep it in the mind. It's like our internal memory. Then according to the error, it will give the output layer value. After 2 minutes, I will continue this Sebig zeta converter. Okay, now I will explain about the next bidirectional converters. So in yesterday's section, I have explained about the DC to DC converters, boost converter, then SEPI converter, after that low converters. In the boost converter, it's having one inductor and one capacitors. So because of that, its voltage output voltage gain is 1 is to 1.5 only. But in the SEPI converter, I have told 1 is to 8. So similarly, the advanced version of the loop converter is the zeta converter. Its output voltage gain is 1 is to 8 or 1 is to 12. It depends on the inductor. So if you use normal bidirectional buck boost converter, its gain is 1 is to 2. For example, let us take 300 voltage DC link voltage. If you use any normal bidirectional buck boost converter, it will convert the 300 voltage into 150 volt only. So you have to use almost 15 batteries. So if you use 15 battery, then only you can store that much voltage. But if you go with this kind of high gain converters, that 300 voltage has stepped down into 60 volt with the help of zeta mode. Similarly, same 60 volt we can boost into 300 volt with the help of SEBIC mode. So we can reduce the solar number of solar panels as well as number of batteries. That's why we are going to merge the high gain converters. So this is the circuit diagram for SEBIC as well as zeta converter. So the input side is the SEBIC converter and output side is the zeta converter. In input side you can see one inductor, one capacitor and one switch is there. Similarly in output side also one inductor, one capacitor and one switch is there. The switch M1 is used for boost mode and M2 is used for buck mode. That means in charging, under charging, M2 will work, under discharging, M1 will work. So if we club these two converter, our input current also continuous, output current also continuous, so that we can expect high gain output with less number of PV system and less number of PV batteries. Then next one is SOC monitoring. In battery, state of charge monitoring is very very important one. In the electric battery, this is the important thing. If our SOC is zero, our battery we can tell it as empty. If our SOC is 100%, then it is full. This is the simple ratio between the SOC and battery energy. So if our battery storage capacity, that means it loses means 0% means we have to charge completely. So the safest SOC is 80%, 60 to 80%. If your energy falls down into 60%, immediately we have to charge the battery with the help of input energy resources. The next one is the SOC estimation. From the SOC estimation, actually have to monitor the SOC very clearly. So with the help of artificial neural network or any physiology control technique, we have to train the data, initial data SOC. Then from the current value, it will give the SOC, estimated SOC, how much percentage energy is there. Like that, we can see it. Next one is battery and solar monitoring system. Battery as well as solar monitoring system. So why we have to monitor the energy means nowadays we are replacing all the old energy resources into that means petrol based, chemical based, then thermal power plant, nuclear power plants. We are replacing into renewable energy resources, but they are investing. For example, let us take one company from Pune. They will invest in our Tamil Nadu. They have to monitor the SOC of the battery, PV voltage, PV power, and PV current. So many things he has to. They have to monitor all. If we use human being, what will happen means manual error will come. That's why we are moving to IoT based monitoring system, Internet of Things we can use it, or mobile based monitoring we can use it. So these are the two options to monitoring the energy storage system as well as PV system. So initially here we have to know how much voltage is there, how much current is there, and how much temperature is there. So three things we have to monitor. So I will explain about sensor. So what is sensor means? Generally we will tell it is a device which, used to measure the input data, but that's not a correct answer. Sensor is a device which is used to convert the physical quantity to electrical quantity. That is the correct answer. Sensor is a device which is used to convert physical quantity into electrical quantity. How it's converting means, uh, let us take one temperature sensor LM35. In the temperature sensor inside thermistor is there. So thermistor means thermal resistor only. Thermal resistor means R. If temperature falls with this sensor, so if temperature increases means automatically we know electrons will flow. So flow of electrons we can tell it as current. So I into R, we will expect I into R is equal to voltage. So this is the way sensor will convert the physical quantity into electrical quantity. Similarly, the voltage sensor and the current sensor, that's also electrical device. The output also we will get electric. So from the sensor we will get voltage, current, temperature, and anything we can measure it. After that we have to transmit it to IoT web page as well as any one of the GSM module. So for that here we have to use one microcontroller. That microcontroller. So what is microcontroller means? It is a device that will operate under the operating frequency of megahertz. So in the production procedure of the IC, integrated circuit, is in LIC we have studied the first unit is silicon wafer preparation. In the IC fabrication step, the first one is silicon wafer preparation. So we know silicon wafer means it's sand only, and the sixth step is ion implementation. So ion implementation, ion is the conductor and sand is the insulator. If we combine these two, we will get which material? Semiconductor material. So semiconductor means partially conducting device. Semiconductor means partially conducting device. So at one particular temperature only, that will work as from insulator to conductor. That voltage we can tell it as cut-in voltage or pinch off voltage or breakdown voltage. So there are three names are there: cut-in voltage, breakdown voltage, and pinch-off voltage. So this voltage has defined with different logic families. In the digital electronics, we have studied about different logic circuits, TTL family, ECL family, and CMOS family. TTL means transistor logic family. CMOS means complementary MOSFET family, complementary MOSFET. So MOSFET means metal oxide semiconductor filled up with transistor. Then ECL, emitter coupled logic family. So among these, the microcontroller comes under TTL family, transistor logic family. That's why we are providing 5 volt DC as input to the microcontroller. So 8051 is the first version of the microcontroller. Okay, now operating voltage is 5 volt. Next we have to fix operating frequency. So operating frequency is defined with the help of crystal oscillator. Oscillator is used to produce oscillated waveform, that is the answer. So the piezoelectric crystal oscillator will produce almost 10 megahertz. With the help of PLL phase lock loop, we are making the 10 megahertz into 20 megahertz or 40 megahertz. So let us take 10 megahertz for 8051 as operating frequency, and operating time is 1 by f. So 1 by 10 into 10 power 6, almost it will come 0.1 into 10 power minus 6 seconds. So 10 power minus 6 is micro. That's why this controller is called as microcontroller. So the 12th advanced version of the microcontroller is the Arduino controller. 12th advanced version of the microcontroller is the Arduino controller. So Arduino controller operating voltage is 5 volt and operating frequency is 16 megahertz, 16 megahertz, and it's having 28 pins. Total number of pins are 28, and the programming language is embedded C. So these all are about Arduino controller. Then why we are choosing Arduino controller for IoT applications means, so a lot of programs are available in the open source in our website itself. That's why this is the first reason why we are selecting the Arduino controller. Then cost is very low, programming is very easy, implementation also very easy, connection also very easy in the Arduino controller. These are the reasons why we are choosing Arduino controller. So 8051 is the first version of the microcontroller, and the 12th advanced version is the Arduino microcontroller. And the operating voltage of the Arduino controller is 5 volt, and operating frequency is 16 megahertz. So for actually for GSM, directly we can connect the GSM module, global system for mobile communication, and SIM is the subscriber identity module. So this GSM, global system for mobile communication, operating frequency will come in nanoseconds. So but our system will give the voltage parameters up to at 10 power minus 6 seconds. So this GSM will make 10 power minus 6 seconds into 10 power minus 9 seconds, so that the value will get passed through immediately, very immediately to the receiving end. So if you use in one free SIM card, that means free message SIM card, that will send the voltage value, current value, power value, transformer, current value, voltage value to the IoT website. So, but for GSM, no need of Wi-Fi module, but for IoT, we have to use Node MCU, like that means Wi-Fi module. If you use Wi-Fi module, it's in the IoT web page, it must have some IP address. Same IP address we have to write it in the which one? Our Wi-Fi module. So both are gets connected in parallel, so that if we give any parameters to our system, that means Node MCU module, immediately we will get the response in the website. So this is the way we can monitor all the batteries, all the solar panels. So and this is the flow chart, how we have to generate the, we have to monitor the SOC. First we have to read the battery voltage, then we have to compare the battery voltage and the reference voltage. If any error is there, we have to adjust the reference signal amplitude. If it's not a problem, it's we can solve everything, and finally we can monitor the voltage, current, and power energy of the battery as well as PV system. So these are the advantages of the proposed system. means our converters. So now I am going to explain one MATLAB simulation. So this is one of the electric vehicle grid-tied charging station, grid-tied EV. So in MATLAB, we have to use one block named as power guide block. So it's like a header file. So it is the header file for the MATLAB. Next one is PV panel. For PV panel, two inputs. First one is the temperature and the second one is the irradiation or intensity. So with the temperature and intensity here, I have varied from 980 watts per meter square to 1000 watts per meter square. If we vary these two, definitely we will get variable output voltage from the PV system. After that, I have used one converter, that is interleaved type converter. So for interleaved type converter, input side we have to connect only one DC source is enough, but in output side we will connect it in series. So here you can see I have used transformer as inductor. That means mutual inductance. So because of this, magnetic flux problems will not produced in the inductor. Then these two switches will give interleaved output voltages. Then the diode will provide dV by dt as well as snubber protection. dV by dt as well as snubber protection. Then the capacitor will maintain it will give the output voltage to the next load. Then we have to control the DC to DC converter. So here I have assigned the reference voltage is 600 voltage. Then the reference voltage 600 and the actual voltage we are comparing, that error is given to one PI controller. This PI controller will make the high value of error into less than 1. High value of error into less than 1. After that, this one is combined with the carrier signal. This one is combined with the carrier signal, and finally we will get the PWM pulse. So during 0 to 45 degree, one switch will come. 45 to 90 degree, another switch will come. So this one is used for transporting the delay. So anyhow, reference voltage minus actual voltage, and the error is given to PI controller. PI controller output is combined with the carrier signal, and this carrier signal having amplitude as 1 volt. Then finally we are giving this voltage, 1 voltage to the 1 volt reference and 1 volt carrier. We will get a PWM pulse, and that pulses are given to the switches. So it will convert the output voltage to 600 volt. Then later we are giving this DC voltage to one 3-phase inverter, and the inverter output voltage has connected with the motor, BLDC motor, brushless DC motor. So in the BLDC motor, already yesterday I have told this is not a pure DC motor and pure AC motor. It's an electronically commutated DC as well as AC motor. So first one, for electric vehicle, we have to assign the reference speed. So how much RPM we are assigning means 1200 as the reference speed as well as set speed. And this speed is combined with the actual speed of the BLDC motor, and the error is given to PI controller. So yearly the same function the PI controller will do it. It will convert the high value of error into less than 1. That is given to decoder section, because so I have told the BLDC motor having permanent magnet. Because of the permanent magnet, we have to know the rotor position. Without knowing the rotor position, we cannot run the BLDC motor because jerk problem will come. So in order to overcome the problem, we have to watch the rotor position very clearly. So from the Hall sensor, actually let us think the 360-degree circle is there. In between the 360-degree circle, 3 Hall sensors are mounted 120 degree mechanically, electrically, 60 degree mechanically. So we have to check it whether from right to left or left to right. That's why we have assigned one NOT gate. So NOT gate will give inverted waveform. So if you check the HA and HP bar or HC and HC bar, HD and HD bar, it's no use. So instead of that, we will compare HA and HB bar. Similarly, HB and HC bar, HC and HA bar. Then vice versa. Then here we will get the output. If both are same right side in between HC and HB bar, at that time the output of the AND gate will be 1. If any one of the input is 0, we can assign the rotor is not nearer with the stator side. So it's not possible to run the machine. We can run it, but jerk problem will come. In order to reduce the jerk only, we are doing the rotor based one for EV. Then we are creating the PWM pulse. That means the reference and the carrier signal. Initial duty cycle is 0.1 with the error, with the output of the error. Then we are comparing the reference and the carrier signal. We will get error. That error is added with the output of the PI controller. So this one. So if we compare these two, that means PI controller output and the rotor position signal, we will get PWM pulse. If we give this PWM pulses to the inverter will convert the DC into AC. Then this AC is provided to the BLDC motor. Now the motor will run. Okay. Then final questions. Here, what is the final question? Means from PV in during daytime we will get the energy and we can give this energy to the DC to DC converters, or from DC to DC converters we can give to 3-phase inverter. Then through 3-phase inverter we can run the BLDC motor. But during night time, as well as if our vehicle is not running, means at that time total energy storage is wastage only. So we are going to grid tied concept. So we are going to grid tied concept. Let's see here, one capacitor is there. So this inverter is called voltage source inverter. In inverter there are 3 main types: voltage source inverter, current source inverter, and the combination of the Z source inverter. So some of them will tell you the inverter shape is Z. That's why the inverter is called Z source inverter, but that's not the correct answer. In voltage source inverter, in between the switch parallelly capacitor is connected. In current source inverter, next to the DC source, inductor will be there. So if we combine these two, capacitor and inductor, that inverter is called as the Z source inverter. In Z source inverter, that inductor, that capacitor will work as the second order low pass filter. It will work as the second order low pass filter. So it will reduce the ripple content also, and it will increase or it will boost the output voltage also. So in voltage source inverter, if we give high amount of voltage, output will be less than that voltage. That means voltage source inverter will work under buck mode. In current source inverter, next to the DC source, one inductor is there. So V by L or V by Z is equal to I. So due to that, V by I is Z is equal to I. That's why it is named as current source inverter. In current source inverter, 50% of the energy we can expect more than that of the input. So current source inverter will work in boost mode. So if we combine these two, buck mode as well as boost mode, we will get Z source inverter. So Z source inverter is nothing but DC to AC inverter only, but it consists of one voltage source inverter and a current source inverter. So anyhow, here we are going to is voltage source inverter only, because in current source inverter power losses are very high. Then this inverter will convert the DC into AC, but the problem in grid we will maintain 230, but inverter output side we can't expect 230. If our inverter output is 230, at that time grid voltage will vary. So here we have to do two variations. First one is we have to do some achievements, grid synchronization technique. Yesterday also I have explained about the grid synchronization. Initially we have to assign the reference power. So how much watts I am giving means going to give means 500 watts as reference power, and it is compared with the actual power. So reference power and the actual power are compared, and the error is given to PI controller. The PI controller output is the current signal, but the shape of the current signal will not be a sinusoidal, so we have to make it into sinusoidal. That's why we are multiplied with per unit of the uh, multiplied with per unit of the grid voltage. So here grid voltage shape is sinusoidal, so this one will convert into sinusoidal. So this is the reference current, and we can compare the reference current and the actual current. Finally we will get PWM pulse. That pulse we can apply to the inverter, so that our inverter will maintain three operations. First one is achieve three performance, grid synchronization performances. That means amplitude will be same, power will be same, then frequency also will be same. This is single phase, so phase sequence is not a problem. So this overall structure is the entire electric vehicle charging station as well as electric vehicle based EV. I will run the simulation. So with the 25-degree and 1000 intensity or irradiation, we got 179.2 voltage as input to the converter, and the power is 4500 watts. Then here you can see the output voltage. Our requirement is 600 voltage. Here also we are getting the output as 604. In the PI controller, 10% errors are allowed, but we got only 4 voltages more than that of 600 voltage. So this is the use of the converter. So this converter can increase the output voltage gain. Next, in the motor side, so our reference speed is 1200. Our motor also running at 1200. Then the BLDC motor back EMF is trapezoidal shape, and this is the torque waveform, and this one is the current waveform. So starting current and starting torque are high, but during running it comes to normal. So in the BLDC motor, the difference between the BLDC motor and the PMSM motor is only the back EMF difference. For BLDC motor, the back EMF is trapezoidal shape. For PMSM motor, back EMF is sinusoidal shape. After that, grid side. In the grid side, this is the grid voltage waveform, and this one is the grid current waveform. Then you can think about the real and reactive power. The reactive power is almost zero, but real power we have assigned 500 watts. We are getting 500 watts also. So this is the grid tied EV with the grid synchronization and closed loop based PI controller. So after 3 minutes, I will explain the next one converter, DC to DC special converter. Okay, so this is the next bidirectional converter. I have integrated the uh, interleaved boost converter and another one is interleaved cuck converter. So through this formation, actually number of switches is high, but we will get high output gain as well as high attenuation gain also. So same PV panel output voltage is given to our this proposed converter. Here we have used only one number of PV panel. That means single source is enough. In the output side, we have connected the two converters in series. So here we will get almost a huge amount of output gain. Then similarly, if we use any grid connected application, this converter will be very suitable. That means for boost can move under boost mode also two switches will work. Under buck mode also two switches will work. But in normal bidirectional buck boost converter only two switches are there. The single switch will be work under boost mode and another one switch will work for buck mode so that switching stresses and switching losses will be very high. But these kind of converters will give effective way to reduce the switching losses as well as switching stress. So once again today I will recall all the sections. Why we are going to energy storage system means the energy storage system with the battery as well as super capacitor. It can store the energy from the PV as well as wind energy conversion system or any other input DC as well as AC sources. For battery as well as super capacitor, it cannot store the AC voltage because the AC voltage in AC voltage positive cycle we will get charging and the negative cycle we will get discharging. So resultant voltage will be zero. So we cannot store the AC voltage through rectifier. With the help of rectifier, we can convert the AC voltage into DC. After that, we can store the DC voltage in battery. So the energy storage system, different type of energy storage systems are is fuel, mechanical spring, electromagnetic or electrical capacitor, biological glycogen, electrochemical battery, our proposed battery energy storage system, and brick storage heater, then chemical biofuels. So this is the working diagram of battery. It's having two electrode. First one is positive electrode and another one is the negative electrode. So in between the positive electrode and the negative electrode, we will get variable DC voltage. So this is the main diagram. Once again, I will explain the diagram very clearly. PV panel, it will convert the sunlight into electricity. That PV panel output voltage is given to the DC to DC converter. This DC to DC converter will make low voltage DC into high voltage DC. The MPPT algorithm is used to track the maximum power from the PV system with the help of DC to DC converters. For electric vehicle applications, compared to for electric vehicle application compared to normal non-isolated converters, that interleaved converters are very good one. In the MPPT algorithm, instead of P and O or incremental conductance algorithm, we can use algorithm or neurophysiologic algorithm or any of the optimization technique to achieve the convergence. Then our inverter will convert this DC into AC, and that is fed to the grid with the help of LC filter and grid synchronization technique. Without grid synchronization technique, we cannot achieve the parallel operation. And the grid synchronization concept is we have to compare the reference power and the actual power, and the error we have to give to the PI controller, and the PI controller output we can compare with the reference sinusoidal signal, and we will give this PWM pulses to the inverter. So after this PWM pulse only our inverter will convert the DC into AC. Similarly, next one is DC charge, that bidirectional converter. In the bidirectional converter, battery is used to store the energy. After that, battery management system, that means through SOC monitoring, we can use artificial neural network or convolutional neural network or deep learning or recurrent neural network. So many neural network concepts are there. We can use that machine learning as well as deep learning concept to monitor the SOC. With this SOC, we can control the bidirectional DC to DC charging converter. So after that, this EV charger or EV motor, for EV motor, our DC charger will give variable DC voltage. It's like a chopper. So this is the commonly used bidirectional DC to DC converter. It's having one battery, one inductor, two capacitor and switches. The switch S1 is used for boost mode and S2 is used for buck mode. In practical implementation, so I will tell some points about the practical implementation, how it's possible to implement all the circuit means. First one, have to choose PV panel very clearly. Don't use small power rating PV panel, because if you go with on 10 watts solar panel, they will charge nearly 700 to 800 rupees. I'm telling about the Tata panel. If you go with the 100 watts panel, the cost will come 3000 or 4000 only. So first you have to choose good power rating. After that, vehicles. For vehicle motors, the best one is the BLDC motor. So I told about the brushless DC motor and the reasons. The BLDC motor power density is high, speed rating also very good one. Then torque ratio. So many advantages are there in the brushless DC motor. After that, converter already I have told. Interleaved converters, interleaved loop or interleaved SEPI converter is the best one. For this converter controlling technique, if your output is normal standard load, you can go to MPPT algorithm. But if you want to do grid connected topology, which one is best means our closed loop optimization is the best one, because in grid connected topology we have to control the total harmonic distortion, we have to limit the total harmonic distortion. So to reduce the total harmonic distortion, we have to give constant DC input voltage. If you use normal input AC voltage, normal, if you use MPPT algorithm, we can get constant power applications. But for this grid connected topology, power is not a problem. Input voltage is the important thing. So closed loop optimization is the best one. So why we are going to optimization means to reduce the settling time problems, maximum peak over problems. Instead of normal PI controller, if we go with optimization technique, we can tune the output of the converter. So in the hardware implementation, these are the power circuit, battery converter or DC to DC converter, three-phase inverter. These all are normal power circuit only. But here the control circuit is very, very important. For the control circuit, the best one is FPGA controller, field programmable gate array only. In FPGA controllers, pattern 3 and pattern 6E, two options are there. So instead of pattern 3, we can go with this pattern 6E. The FPGA controller operating voltage is 3.3 volts, but while we implement it in the hardware, to drive the MOSFET as well as IGBT, we have to give 15 volt PWM pulse, 12 to 15 volt PWM pulse. So to convert the 5 volt PWM pulse or 3.3 volt PWM pulse into 12 to 15 volt PWM pulse, we have to use driver circuit. So driver circuit means optocoupler. It is the combination of photodiode and phototransistor. For photodiode, we will give the PWM pulses through one resistor. So the LED will glow. So through the LED light, the phototransistor will take the light as input signal. For photo transistor, we have to additional 15 volt DC supply from output side. Because of this, what we will expect means we will convert the 5 volt PWM or 3.3 PWM volt PWM into 15 volt PWM. So without this driver circuit, we cannot run the BLDC motor through inverter as well as DC to DC converter, normal DC to DC PV converter, or normal DC to DC bidirectional converter. This driver circuit is compulsory for all the MOSFET as well as IGBT circuit. Then protection circuit. So if we use electric vehicle concept under running, it will take initially starting current. So huge amount of starting current it will take. So due to that, IGBT may damage. So to overcome this problem, short circuit or any one of the problems, simply have to use protection circuit. So without the protection circuit, we cannot complete the hardware also, because if current increases means automatically our equipments will get damaged. So for that we have to use one Hall effect current sensor. With the Hall effect current sensor, we have to compare the reference current and the actual current. The reference current means maximum capacity of the switches. So that reference current and actual current we can compare it. If your current reaches more than the threshold value, immediately we have to cut the PWM pulses from the FPGA controller. So this is the way we can save all the devices in the electric vehicles. So the best controller for designing EV is FPGA closed loop controllers. You can select induction. But if you go with the normal gas induction motor, you can use induction motor advantage, means we can reduce the switching losses as well as DC voltage utilization. So this one is SVPWM is best for the three-phase induction motor applications. If you want to PMSM motor, we have to use vector control technique. Without vector or FOC field oriented control, that is not suitable for EV application. So finally, I am suggesting the electric vehicle application with special electrical machines. PMSM, BLDC, or finally switched reluctance motor. So thank you. If you have any questions, please ask to me.
Sir, actually, I mean to say that the beauty of that vehicle, EV, will be lost if in case we use solar in case of cars.
Yes, sir. For that, yeah, I have checked your message in chat box, sir. Uh, for a train and bus, this is the very good one. For car, you can go with charging station, sir,
Okay.
for luxury purpose.
Okay.
Kavin sir,
Ma'am.
கம்ப்ளீட் பண்ணிக்கலாமா சார்?
Okay, ma'am. Okay.
இல்லை உங்களுக்கு இன்னும் செஷன் கண்டினியூ பண்ணுறேன்னா பண்ணிக்கலாம். நீங்கள்
இல்ல,
3:15
இல்ல.
சொன்னதுனால கேட்டேன்.
Enough, ma'am.
ஓகே சார்.
Okay, ma'am.
Participants, do you have any clarifications? So if you have any clarifications, I will give you Kavin sir mobile number. You can contact him directly. We will wind up the session now. Thank you, Kavin sir.
Okay, ma'am. Okay. Thank you.
The feedback and attendance link I will provide you in the staff WhatsApp group. Thank you.